Cool, guys. Well, my name is Vadim Rozenfeld. I'm working for Red Hat for quite a long time, since 2007, and all the time I was involved in virtio development. So I'm behind several drivers in virtio. You also can find my fingerprints on Hyper-V stuff. But today we are going to talk about adding Microsoft support clustering, running Microsoft clustering on top of QEMU, and basically the steps that we did to make virtio-scsi be one of the couple to run Microsoft clustering on top of virtio-scsi. We are going to talk a little bit about cluster itself, about iSCSI, because iSCSI is still one of the valid solution, and it works. It's pretty stable. It works pretty good for clustering. As well as we are going to talk about virtio-scsi. What was our reason? What is our motivation to add support to this existing virtio-scsi driver? The step was done making its, virtio-scsi driver clustering aware. The changes from inside of virtio-scsi driver itself, also changes from QEMU side, and a couple of words about our current status. Well, if it turns to clusters, so there are a lot of definition of what technical cluster is, but basically we know that the idea is just to improve availability and scalability from one point of view. From another point of view, the definition of cluster, it's a group of independent systems running together. So we have several nodes, at least two, running together, and we have three different kinds of connection between those nodes. Basically, we have public network. It can be Ethernet. We also, two nodes should be connected by some kind of private network. Well, technically it shouldn't be. It's not a must to be connected through private network. It's just kind of recommendation from Microsoft side. And they also should be connected to the same shared storage. Also, speaking about cluster, since it's a kind of distributed system, should be some kind of health monitoring mechanism running inside of the cluster. It's why we have this private network, mostly for tagging heartbeats. For Microsoft, it's not just a standard ping. It's something a little bit different. It's more like a handshake. And well, basically that's it. There's nothing special about cluster itself. And then we come to another issue, it's failover cluster, because failover cluster usually has, as I said, at least two nodes. It can be more. Windows 2012 R2, if I remember correctly, it's supported up to 64 nodes in cluster. And how it usually works, we have let's say node 1, which currently active, and we have request coming from client, and then for some reason if node 1 just crash, it should be bring down, then node 2 will take over, and from the user, from the client's point of view, it will be absolutely invisible. It should be absolutely invisible. And there's another question, the question about how shared storage should be connected to, how we connect shared storage to those nodes in the cluster. Microsoft supports several solutions. One of them is iSCSI, another one is serial SCSI, SAS, and another one fiber channel. There are several kind of variations, for example, like fiber channel over Ethernet. SAS is also, it can be different kind of SAS, like just bunch of disk or just redundant bunch on disk. Technically it doesn't matter. What we know, there are three major interfaces to work with clustering: iSCSI, SAS, and fiber channel. iSCSI we already have, so basically we don't have any problem. We can use iSCSI as a reference, and let's see if we do modify our virtio-scsi driver, if we get any benefit from that or no. And here is about iSCSI. Setting up iSCSI connection in Windows Server is pretty simple. We basically need to activate iSCSI initiator. There are 3 pages. We just need to fill up them, and then we just need to configure our iSCSI target. For all my development, for all my experiment, I use what they call Linux IO targets, developed by Titara, I believe. Yeah, it's pretty simple to set up the system. Doesn't take a lot of time, and then technically in several minutes you can have this set up ready and ready for run, ready for testing. And the idea was just build 2 different setups. One based on iSCSI solution, another one on virtio-scsi, and check and see if we really get any benefits from using virtio-scsi. So the idea was just run several stress tests inside of one configuration and another, just to get some numbers to compare and make decision. And when we speak about running performance test, one of the most simple solutions which came to the mind, it's just running IOMeter. It's very simple, very powerful. You can just run it also in several minutes, just install, run it, and get some results. We decided to check 2 different loads, 4 kilobyte blocks versus, and also 256, just to see how virtio-scsi behave comparing to iSCSI. And result, they really were not so bad. So we were better than iSCSI for 4K read and write test. We also were better than iSCSI for 256 requests. At least for read, for write it was almost the same. But as I said, IOMeter is a kind of synthetic test. It can give you a lot of information, but after all, you definitely need to get other kind of information from different performance tool just to make a decision. And you just need to create some sort of real life load, like for example like SQL Server or Microsoft Exchange Server. And it's pretty doable nowadays, because Microsoft, they have what they call Microsoft Exchange JetStrace. It's a kind of standalone tool. You can just install this tool. It doesn't need, basically we install just binaries. You also need to copy several binaries from Microsoft Exchange Server, but unlike SQL Stress, you don't need anything else. You just install this test and you can run it. The minimum test takes around 2 hours. It's a very powerful tool, by the way. This test creates a lot of load inside of the guest. It's require a huge amount of different performance counters, including CPU, including file system, including cache, memory, and disk. But for our test, we are mostly interested in two parameters. One of them is IO database read, average latency, and another one is IO log write average latency, because there are two key characteristics for let's say for SQL Server or for Microsoft Exchange Server. And for that test, we also, I mean, virtio-scsi is also a little bit better than iSCSI. Well, frankly speaking, both of them are bad, but you know, virtio-scsi is better, because we can see that, you know, that average latency is quite small for virtio-scsi. And then, basically, it was a key point. We decided, yeah, let's try to make virtio-scsi device driver to be aware of clustering. And the first thing that we did, it's pretty obvious, because we know that it should be SAS, it has to be serial SCSI disk. We just know change it one single line in INF, you know, hoping that it will be enough. You just know changing bus type from SCSI to SAS, and build driver started run. For failover cluster validation, Microsoft has a very good tool. It just comes together with activating failover clustering feature. The name for this tool is Failover Cluster Manager. And as part of this Failover Cluster Manager, they have validation wizard inside. And it's a very powerful tool, because there are 4 different categories inside of this tool. One of them, and just the first one, it's inventory, because when we run this tool, this inventory test just get all information about your hardware, trying to find if we have any hardware capable to work with Microsoft clustering. And the first time we ran this test, you know, it was kind of really bad. We expected it, but you know, in any case, it was a little bit depressing, because you know, Failover Cluster Manager just didn't recognize our device as SAS, as serial SCSI HBA. So something was missing. Even so that we made the changes in INF, something still was missing, and we started to dig inside this problem. And the first thing was just, you know, just take any sort of existing solution and see how it works. And the existing solution was Fusion, VMware Fusion, because they have fully emulated LSI SAS device. And we tried to build failover clustering on top of VMware Fusion, try to run the same test, and well, LSI SAS device was just mentioned in this list. So something was wrong, because you know something was missing from inside of our driver, and we started digging in this problem. The funny thing was that we tried to trace all requests coming from this validation cluster manager. At the moment when we run this application, all requests coming to our driver. And the interesting thing was that, you know, no SRBs, no YOCTL were coming from our driver to our driver. So, you know, for some reason, it was like, even before touching our device driver, Failover Cluster Manager already knew that we are not good. And yeah, and it was kind of interesting situation, because from one point of view, our application, without even communicating with our driver, can know that we are not good. From the other point of view, Microsoft has a wonderful, very powerful thing integrated into the operating system itself. It just leaves also in kernel and user mode, but the name of this thing is Windows Management Instrumentation. It's WMI. It's technically built for to simplify machine management, but not only. We can also look at WMI as a kind of database which requires a lot of information from the drivers, from the software, if software definitely wants to publish this information. And if we look at the stack, at WMI stack, we see SCSI miniport driver almost on bottom of this image. So SCSI miniport driver should provide something, should provide some kind of information that we didn't provide yet. To make basically to notify Windows that we do support Microsoft clustering. And well, at that point we just started studying LSI SAS driver. Just trying to disassemble it, well, to see what technically happens inside stuff. And one of the functions basically implemented by miniport driver is kind of WMI initialization function. And we started dig inside of this function, trying to disassemble it and see what's going on, what's inside. And as you can see, part of this function just initialization of SAS global UID list. And looking into WDK documentation, pretty easy to find this structure, because we have the structure inside. We have basically one number. First of all, we have what they call SCSI WMI lib context. It's a pretty huge structure. One of the members of the structure is SCSI WMI UID reg info, which contains pointer to global UID. So from that point, it was pretty much easy, pretty much simple. We just can go try to disassemble it forward, and well, here it is. We found two numbers basically. You see, there are three, but well, two are most interesting. And you have kind of byte stream. You just need to rebuild a GUID from that byte stream, and then just back to WDK. Those two classes, they are defined inside of WDK. So, which means that there are two classes, two WMI classes that we need to implement. One of them adapter information query, and another one is port information method. And as soon as we managed to implement this stuff in the driver, build driver, run driver, it was better, because Windows recognized that our driver as a valid serial SCSI HBA, and we just moved a little bit forward. The next step was part of storage validation test, and at that stage, Windows, this cluster manager tries to find, tries to figure out if disconnected attached to HBA is eligible to be used for clustering. And at that moment, you see it just was false, and it was also kind of very interesting information, because we knew that disk, because if you go to Microsoft website and try to find any information regarding to eligibility, it's very simple. The list is also it's pretty simple. Your disk has to be base disk. It can be GPT or mass booster, MBR. It shouldn't be a system. It has to support SCSI 3, and it also needs support persistent reservation. We try to see what's wrong, what's going wrong, because we haven't seen any request regarding to persistent reservation at that level. This was basic. It was formatted as NTFS, and everything looked like we fulfilled all the requirements. And then, well, we started looking into log file coming together with this test, and there are two messages like, is cluster supported? And well, see the result is the result message that that port driver does not support clustering, and this message is extremely misleading because when you think about port driver, we are even not at the level of port driver. We are sitting a little bit. We are sitting beneath of that port driver, and we even don't own this port driver because it's part of Microsoft distribution. And well, we started. We tried to figure out what's wrong. The first thing that we did is just to try to find function is cluster supported as a part of cluster manager key toolset. We were trying to find it inside of binaries, and yeah, finally at some level, yes, we found this function exported by cluster DLR, and it was good. Yeah, because well, because by disassembling this function, we managed to find that the piece one of the pieces that was missing, it's what Microsoft call it's one special IOCTL. It's one special IOCTR SCSI miniport not quorum capable. And another thing that Microsoft sent it through IOCTL SCSI miniport IOCTL, which is kind of handshake between application and miniport driver. And the problem is that this stuff is not documented, really. And it's a kind of once again, it's a kind of handshake between application and storage vendor. As soon as we implemented this quorum-capable IOCTL, it was better because we managed to pass all storage-related issues except for probably the last one, and this one was related to persistent reservation. And the funny thing was, because we knew that persistent reservation works with a backend. It works pretty well with the Itara backend. But for some reason, it was failing when we use QEMU stuff. But it was obvious that probably some problem inside of QEMU. And after debugging this stuff, after basically tracing this stuff, we managed to find this problem. This problem was fixed by Paolo. It was pretty elegant solution. The problem was just when we use persistent reservation, target notify the initiator with SCSI status block, SCSI status. And this SCSI status, support for this SCSI status, was missing inside of QEMU. It was almost fully implemented for IOCTLs, but for read and write request, it was just absolutely missing. And after Paolo fixed this problem in QEMU, well, we managed to pass all this tests. We managed to build our cluster and just handle it to to QE for testing, and here is the current status. For now, we know for sure that this solution works pretty well with iSCSI backend. It also works for fiber channel. We're expecting to get more results, more backends in the future. If any one of you wants to try it, you are welcome. Just try to do it at home and get back with the results. We'll be happy to get any feedback from the community. Well, that's it. Well, any questions?
We don't have time for questions.
Okay, that's good.